What's up guys, it's Minx. In the last video we created our GUI for designing levels. In this video we're going to start spawning level objects with our GUI. There's a couple pieces of setup, so we're not going to have drag it, drop it, and then it'll be added to like a level thing. But we're going to set up the framework to get this working, and we are going to have objects come out. They just won't be actually placed just yet. Good news is this is fairly simple, so in the next video we should be able to get fairly far with this. This will be pretty quick, so that's pretty cool. Let's go ahead and get started. So there's a change I want to make to something that I should have done a while ago. I didn't think it would be that relevant, is I want to get the mouse position on screen as a variable. So we just create a little vector2 next to the other one. Let's see here. So in game window, I want to make a public vector2. I'm going to call it mouse screen location. So this is essentially going to be the adjusted camera or adjusted location of the mouse based on where the camera is. That way we're not like having to do that calculation every single time we want to access this. So I'm going to add it here and we're going to use it moving forward. However, for something like what we did in the last video, I think we did that on our menu, if I'm not mistaken. Yeah, we took it here. So we took lm.screen. Oh no, this is the, did we do it for the hover? It was for the hover, right? Yeah. Well, I guess I could just replace this because it'll be accurate. So we'll do that. But I just want to do the same math here so we can actually steal this. So mouse location.x. Well, we don't want to steal it because we don't need to qualify it like that because it doesn't work. So we're gonna go into, let's see, I want to do in the update, I think. Yeah, on update. Here we go. And I want to do it first. So we'll say this dot mouse screen location. So this dot mouse location minus this dot camera. And this will automatically subtract the vectors. We can see that this vector dot operator minus, and it'll subtract the x and y of camera from x and y of mouse location to get us the correct mouse screen location. This way we don't have to keep saying this every single time we want to reference that. So now we have a variable we can use, which is not much better, but it works. So that is the biggest thing for that. There is one other thing I want to do here that is sort of like not necessary. Well, I guess it's necessary, but it's not relevant for today. If we go into Game Save Manager, I made a little goof up when we wrote this. We didn't do any testing on it. I was testing like, all right, what are we doing here? We're going to start doing files and stuff. We're not in this video, but I realized that we're deserializing the path rather than deserializing the file text. So we're just going to add a file.readAllText path to file and a second parenthesis here. So this will read the contents of the file rather than the path of the file. So that's my mistake. We didn't do any testing, and that's my bad. I probably should have run it some testing at the time. To test it, what I did was I ended up adding some stuff here saying, hey, we create the object. So I serialized it to a string. I checked the string and deserialized it back into a level, and it worked. So when the time comes to save and load things from files, it should be fairly easy. We should be able to just say, hey, save it to this file. Hey, load it from this file, and everything should be good. So with that out of the way, we can actually close out of that. Oops, I closed out of the wrong thing. I want to close out of Game Save Manager. I don't think we need game window for the rest of the day, but if we do, I want to make sure I have it up. The next thing I want to do is let's head into level block. So level, and in here we have level block. I want to make a change to this. So we have a location and identifier. I figured we were going to need this, but I wasn't sure. I want to make a public vector2, call it scale. Oops. And then add this as a parameter here. So vector2 scale. We'll follow the same principle we used for the other two. Just say scale equals scale. This is because we may have different levels with different scaled objects. We're going to be doing a grid snapping system, which is fairly easy. And then when it snaps to the grid, we also need the object scale to be that same grid size, so it takes up its whole grid piece. So for example, we do a 50-50 grid. It's going to snap to every 50th spot, but it also needs to be a 50-50 piece. So scale, and something's going to be broken here. If we go back to game window, this is actually what I was thinking of, I think. Test level is generating these without set scales because it was just using that. So we're going to set the scale to new vector 2. And for now, for the testing, we're just going to do 50-50. That's what it is anyway. 2. And I think, so when we load the level, we need to actually say, instead of doing a new vector 2, we'd say block.scale. That way it's grabbing the scale rather than doing set 50-50. We're not going to see any change because we're already using 50-50 for our testing, but now we've got it set up so that way we can set that when we want to rather than being stuck with hard-coded numbers. Realistically, should have done that from the get-go. So that's good. Let's go ahead and move on. So we've done this. Let's go ahead and set up our what do we call it? Placeable object. I'm going to call it placeable. So let's hop in here. I was thinking about adding it to levels. So we're going to add it here. We're going to add a new item. I'm going to call it placeable. So this is going to be fairly similar to a wall, actually, because we're placing walls. We're placing sort of objects that aren't going to be really doing anything in testing. All they're going to be doing is storing information about where they are and what they're supposed to do, so that when the level gets loaded, it will load the correct object that it's actually supposed to load, which will have the functionality. So we can actually go over to wall, and we can pretty much copy everything inside the class. We'll add the other stuff later. We do want it to be an iDynamic. I was thinking about doing a custom interface, but nah. So we'll do this. And what I really like is we're copying an inheritable class because we've got it set up with a some virtual methods and variables that allow them to be modified with sub-objects. So we do a placeable and say, hey, I want to do a placeable for this. I want to do this type of placeable. I want to make a placeable player location, for example, or player spawn. So that'll make things kind of easy. For now, we're not going to do all that extra stuff, but we're just going to get it set up so that it functions today. But down the road, we're going to change that functionality. So firstly, we want to make this a iDynamic. So come up to placeable and say iDynamic. And since it's already registering with the code that we've written before, we can leave that. Just want to change wall to placeable because we are creating a constructor for a placeable, not a wall. And let's see here. So what do we need to do this? Okay, so there's a couple things. Firstly, let's add our level block. So I'm going to make it a public virtual because this is likely going to be inherited. So we're going to make it virtual just right now. Level block. And it's going to be, I'm just going to call it my level block, I guess. And we'll just give it a getter and a setter. And then, let's see, I want to do a grid size and identifier. So public int grid size equals 50 by default. I think, so what's going to happen is, I don't think we need to make this virtual because what's going to happen is it's going to load the level, and the level's probably going to be what says, hey, this is my grid size. Your grid snap is going to be based on this, not based on whatever. And actually, so when a level is loaded, it's not, well, okay. So our level creator is going to have to tell it that, not our level loader, because when the level is loaded, all it's doing is loading objects that say, hey, my X and Y is this and this. But when we create a level, that's when we need to know, because that's when the snapping actually occurs. But anyway, we just need a public string for the identifier. So, and we'll say by default it equals A, because that's like our default blue wall here. So these will be changed. Like, so for example, when we call, let's say we go back to our game menus and we say, hey, we want to do was this a blue one, red and a green? We say blue, we say click spawn object, and I still got to figure out, I never actually looked how I would pass through parameters to this. I'd have to look. But we pass through like parameter, hey, I'm spawning this object, spawning that object, spawn with this identifier. That way it tells, it's like, hey, this is what I'm spawning. Anyway, let's go back to placeable. So grid size and identifier. And that's it for that part. We want to say in the constructor, because we want to create the myLevel block, or the level block, I guess. MyLevel block equals new level block, so we need to initialize it. And we need to give it this dot position, this dot scale, and this dot identifier. So just passing through that information, and we'll have to continuously update the position. We shouldn't need to update scale or identifier, because what will happen is if it's like, hey, I don't want this, let's delete this. Now, we may need to update scale if we add something to, like, say we spawn a block and then we like give the ability to like stretch it or something. I'm not a big fan of that because of our culling, because we cull based on distance. So if we're like saying, hey, don't check the collision of anything that's 400 away, and we do a big long 500 with object that are gonna cull, it's not gonna work. So you need to be careful with that. Instead, I think, well, if we were to do that, I'd probably just spawn new objects to the right or above it or something. I don't know, like spawn a grid of them. But anyway, so we got the my level block equals new level block, so that's pretty straightforward. Um, this is where we're gonna override draw. So let's comment out this dot my rectangle, because we're not going to use that. Instead, we're going to say, but firstly, we need to set it to the mouse location. The reason being is, and of course this is going to change down the road where it's like, hey, click, don't use the mouse location anymore. We have our location set, don't move, unless we get clicked on again to move. But we want to say that this dot position dot x is equal to this dot game dot, and this is where it's nice. We got the mouse screen location. Oops. Did I make it mouse screen? Did I make it private or not specify? Pretty sure I made it public. Mouse screen location. Right? I'm not going crazy here. Copy it. Go back to placeable. This dot game dot. Oh, okay. It's freaking out about that. That's fine. And we're gonna say dot x because we want the dot x, and we still want to do some math here. So actually, we're gonna leave it like this, and then we'll fix it later. So it's gonna be a little off from the mouse. You'll see what I'm talking about when we get there, and then we're gonna do the same thing for y. So this will always set the thing to the mouse location. In fact, we could technically spawn the object and it would just follow the mouse around. But before we do that, actually no, let's try that. So if we come, because we're gonna need to do this anyway. Do we have a grid size as a thing? No, and that's okay. Okay. Scale should honestly just be the grid size. Just do a grid size. But let's go to our game menus. So we just need to say spawn object equals a new placeable, and game is equal to this dot game. Position equals this dot game dot mouse location, mouse screen location. And vector 2, how did I do that? Did I just say, hey, we're just doing 50/50s right now? I want to make sure I get that set up right. Yeah, I just did 50/50s. Okay. So I'll do new vector 2, 50/50. It is what it is. We'll fix this later when we do so this is a, I don't want our designer menu to be our quote unquote full on designer where we store everything, but I do want like maybe a designer class or something like that where we have things stored. Like this level is a 50/50 grid size, so we're gonna use that. But for now, it's 50/50. So we should actually be able to spawn an object now. We hit like blue. Okay. Looks like it's not spawning. That's odd. Oh, we're not setting my rectangle. That's why. Okay, never mind. My mistake. My rectangle is empty, so we probably spawned the object, but it didn't actually like show up because our rectangle is where would our rectangle be? We don't even, yeah, it doesn't even create the rectangle. So rectangle is empty. I'm surprised it didn't come up with like a null or uninitialized reference. It's a struct, so it probably spawned at like 0, 0, 0, 0. Anyway, let's go ahead and finish this up. So we actually do. So when I did a new rectangle, I did it in a method. So we're going to say public rectangle. I called it snap to grid, and we did a int grid size, and we're just going to return new rectangle. Rectangle. So we just return this because all we're doing is we don't need to mess the scale or anything. We just need to mess with the x and y. And we say this dot position dot x, and get ready for this rodeo. So first we're going to say it's equal to math dot round, and math dot round is going to take this dot position dot x divided by grid size, and then after it does the rounding, we multiply it by grid size. And then we're going to do the same thing. Actually, we're going to fix this before we do that. So let's see why it's red. So we cannot convert double to float. Are you missing a cast? So we're just going to go in front of this and say the double, because it returns a double, it's equal to float. And actually, oh, it didn't freak out about anything else. Oh, cool. Okay. I guess it converts this automatically inside of it, or it allows us to. So a double is not fully aware of what a double is. I haven't really worked. Let's get it pulled up. I'm pretty sure it's just like a bigger float, but use a double. Floating point data type is used to represent decimal numbers with a high degree of precision, right? We don't need the double. We just need a float. So that's why. So we could put a float into a double because it's, we're not going to lose information. It's guaranteed to keep it. But if we try and convert it back, it's like converting from a float to an integer. We're going to lose some information, which is fine. So that's good. We're going to do the same thing for y and just convert the I to y or x to y. Same thing. So how does divide by grid size and multiply by grid size work? Bring in a notepad here for us. So say it's 100. This will be really easy. Take 100 divided by 50 equals 2. 2 times 50 equals 100. Let's take this to 75 divided by 50. I'm not actually sure what that is. Got the calculator. 25 divided by 50. 1.5 rounded up to, that's probably going to round up to 2. So we get 2. It goes back up to 100. 74 divided by 50. 1.48 goes down to 1. 1 times 50 equals 50. So it'll round to the nearest 50. So that's how that works. And that works for any grid size. So we do like 100, then it'll be a 100 grid size. That's just how it works. So that gives us the ability to do custom grid sizes if we want to do different ones. So now we say rectangle snap to grid is equal to a new rectangle, or returns a new rectangle. So when we go into draw, we update our position to the mouse location. Then after we do that, I want to say this dot my rectangle equals snap to grid, and we'll say grid size because that's what our grid size is going to be. This will automatically call that. And do we need to put anything update? Yes, we need to update my level block. That's not going to do anything for us today, but it needs to be updated. Dot location equals this dot position. So if we were to do this now, we should have a snap to grid block. Boop. Here we go. And we can see it's a little off center. Now, this is not because it's off center from the mouse. I'm talking about off center. I mean, it's like the mouse is up here and it's like, what? We could fix that real quick. So, I mean, if you like it to be a little off from the mouse, that's good. I am not a big fan of it. But you can see the mouse has like about a cube worth of length or a square worth of length here to move around. Because it rounds. So when we hit like the border here halfway, it'll move it down. So what we can do is say, out of this, we can say minus grid size. So this will subtract the full cube. Now it'll be on the other side of the mouse or one block further away. We just divide that by 2. And I want to put that in parentheses because I want that to happen to be calculated first. So right now I'd say minus 25 because our grid size is 50. So if we go in and do this now with grid size divided by 2 for the x and y, level, it goes in the middle. And you can see we can kind of like go anywhere inside the block, but if we like go above it, it puts us at the bottom. So that's kind of cool. I kind of like that. It gives us like our leeway. If our block is bigger, we get a little bit more leeway, or something like that. And because I placed this in like a very specific spot at like 670, like this is going to 650, I think, so it's not even quite halfway through the block. It will kind of just cut it off. So pay no mind to the test level kind of being off center. So this is the first part of this. In the next video, we're probably gonna be placing these down and then like saving it, and then well, I don't know if we'll be saving it. We'll be placing them down definitely, and then being able to select it, and I'll probably add like a little delete thing or something. I'm not sure how that's gonna work just yet. If I wanted like a button or like a you hit the delete button on keyboard or something, I'm not sure. We'll see. But for now, we got phase one done. We're gonna proceed with phase two in the next video. Thanks for watching. I hope you enjoyed and have a wonderful day.